Hey folks, I just want to try something different this time. So here's your first video on the next unit, which is plate tectonics, unit 11. But I don't want you to take notes on this. I just want you to listen. And I'll explain more about that tomorrow when I see you. Okay, so as I said, this is unit 11, plate tectonics. This will be section 1 or video 1. So I want to start off with an essential question. This is a question that you shouldn't be able to answer. Even if you are an expert on this, you shouldn't be able to answer it simply. It's something that we're going to have to explore and try to get to the bottom of. How could a person living today prove that the Earth's continents were once all touching in one large landmass about 250 million years ago? Pretty tough question. How could someone alive today prove that? Or more specifically, how could someone that lived about 100 years ago prove that? And that's what we're going to look at. Well, this is what Alfred Wegener, the W is pronounced with a V, in 1912 proposed. He proposed the idea of continental drift. Now, continental drift is when the continents move very slowly, a few centimeters per year. And he proposed this in 1912 to the scientific community, and the scientific community really didn't accept it very well. Matter of fact, here are some actual quotes, and you can read these. I'll read the first one. It says, "If we are to believe this hypothesis, we must forget everything we've learned in the last 70 years and start all over." That was from an American scientist. Another guy said, "Anyone who values his reputation for scientific sanity would never dare support such a theory." That was a British geologist. So, they didn't really accept this. So how could Wegener prove his hypothesis? He needed some evidence. Anytime you want to make a hypothesis and you have to do an experiment, you're going to get some evidence. So one of the first pieces of evidence that he looked at was the puzzle-like fit of Africa and South America. I don't know if you've ever noticed this before, but it fits kind of like a puzzle, like two puzzle pieces. And he actually had written his future wife, his fiancée, on one of his scientific exploration missions. He went to Greenland, I think the continent of Greenland, 4 separate times. He said this: "Doesn't the east coast of South America fit exactly against the west coast of Africa as if they had once been joined? This is an idea I'll have to pursue." So he did. And actually, he wasn't the first to think about this. There's evidence, there's proof that the early map makers about 300 years ago actually had similar observations about Africa and South America. So Wegener proposed the idea of one massive supercontinent called Pangaea. And here's an artist's representation. And you can kind of pick out today's continents. This would be Europe and Asia. This would be North America, like United States and Canada. Here's Africa. Here's South America. Here is Antarctica. Here is Australia. And this piece of land here is actually India. And so sometimes you hear that India is referred to as a subcontinent. It's not a continent today. It's actually part of Asia because it's touching or connected to Asia, but it once was its own continent. So, but the idea of a puzzle-like fit wasn't enough evidence to make scientists accept the idea of continental drift, that the continents were once together and that they were constantly moving very slowly. So he collected some more evidence. I mean, this evidence was, at least in my opinion, was overwhelming. He studied fossil samples that had already been previously collected from the coast of South America and the coast of Africa. Same exact species, but located in spots that were sometimes 3,000 or 4,000 or 5,000 miles apart. He also analyzed evidence from ancient climates by looking at sediments, rocks that were left behind by the movement of glaciers. And he discovered that these rocks were identical to each other, and these rocks were found on 2 what is now widely separated continents. And then another good piece of evidence was that there are coal beds of coal, just like the coal we mine here, in Antarctica. And we're going to talk more about why that seems kind of strange today. Well, this was a lot of evidence. But it still wasn't enough. The biggest problem with his hypothesis was his fellow scientists asked him to explain how that these gigantic continents could actually move, or what force could make them move, and with enough movement to actually plow, like a garden plow breaking up the ground, plow through the ocean floor. Well, Wegener made a couple suggestions that we'll look at in class, but he really didn't expect them to accept the idea, and they weren't. The scientific community didn't accept his ideas of how the continents were actually moving. So despite his overwhelming evidence that the continents were once together, because he couldn't provide a mechanism of how they moved, his hypothesis was rejected. So remember, he first proposed this in 1912, and it wasn't until after his death in the 1950s that the technology became available. Well, a couple pieces of technology came available that actually came to his defense and proved that Wegener was correct. And the secret was, well, we'll have to wait and see what the secret was in the next video. That's all for now. See you guys.